Hey there, and welcome. Today we're going to tackle something that sounds a little tricky, but is actually super simple: linear functions. All those straight lines you see in math. We're going to figure out exactly what they're all about. And trust me, by the end of this, you'll see it's not scary at all. We're going to break it all down together.
So here's our roadmap for today. First, we'll ask what even is a function. Then we'll meet the star of our show, the linear function. After that, the fun really starts. We'll actually draw a line. Then we'll hunt for some special points on that line. And finally, we'll figure out what makes a line steep or flat. Sound good? Let's dive in.
Okay, first things first. Before we can talk about lines, we got to get this one big idea down: the function. Now, don't let that word intimidate you. Seriously, a function is just a really simple rule. Think of it like a little machine that only knows how to do one thing.
So what's the rule? Well, a function takes one thing in, we call that the input, and it gives you back exactly one thing out, we call that the output. It's totally predictable. The vending machine example is perfect. You press button B4 for the chips, right? You get chips every single time. You'd be pretty surprised if a soda came out instead. That's a function. One input gives you one and only one specific output.
Let's look at a real-life example. Let's say we're climbing some stairs. The number of stairs we climb is our input. The calories we burn is our output. See the table? If you climb one stair, you burn 0.15 calories. If you climb two stairs, you burn 0.30. For every number of stairs you climb, there's only one possible amount of calories you burn. It's a perfect, predictable rule. It's a function.
All right, now that we've got the hang of what a function is, let's meet a really special kind of function. This one is called the linear function, and this is our guy. This is the one that makes all those perfect straight lines.
And here it is. This is it. This is the secret code, the superhero formula for every single straight line. I know, it looks like a jumble of letters, right? But this little formula, y equals ax plus b, is so powerful. Let's break down what each part of the team does.
So in our little team here, x is the number we put in, y is the number we get out, and what y is totally depends on what x was. Then you have a and b. Think of a as being in charge of the tilt, or the steepness of the line. And b just tells us where the line gets started on the graph. That's it. If you change a or b, you get a different line. Okay, enough talking about letters and formulas, right? Let's do something way more fun. We're going to take one of these formulas and actually turn it into a picture. We are going to draw the line.
So here's our mission, should we choose to accept it. We need to draw the line for the equation y equals 2x plus 1. So how in the world do we turn that into a drawing? Well, the secret is just to find a couple of points that live on that line, and then we just play connect the dots. Let's do it together.
The easiest way to do this is to make a quick table. First, we just pick a few easy numbers for x. I like to use simple ones, so I picked -2, 0, and 2. Now we just plug each one into our formula. So if x is -2, y is 2 times -2, which is -4, plus 1, that gives us -3. Okay. Now, if x is 0, y is 2 times 0 plus 1, that's just 1, easy. And if x is 2, y is 2 times 2 plus 1, which is 5. And just like that, we have 3 points, our treasure map coordinates for our line.
Okay, grab that first treasure point, -2, -3. Remember how coordinates work? The first number tells you to go side to side, and the second one tells you to go up or down. So, starting from the very center, -2 means we go 2 steps to the left. Then, -3 means we go 3 steps down. And boom, we plant our first dot right there.
Awesome. Next up, our second point, which is 0, 1. So back to the center we go. The 0 for x means we don't go left or right at all. We just stay put on that middle vertical line. Then the 1 for y tells us to go up 1 step. And there it is, our second dot. See, we can already kind of see how the line is going to look.
Okay, after we put our third point on the map at 2, 5, we get to do the best part. We just take a ruler and connect our dots with a nice straight line. And look at that, we did it. That is the picture of y equals 2x plus 1. Every single point on that line is an answer to our formula. How cool is that? Every line has a couple of really special, important points. I like to think of our graph like a city map with 2 main roads. That horizontal road, the x-axis, and that vertical road, the y-axis. These special points are just where our line crosses those main roads.
And these crossing points have special names.
The spot where our line hits that up and down y-axis, we call that the y-intercept. And the spot where it crosses the side-to-side x-axis is, you guessed it, the x-intercept. They're super handy for drawing a line really fast.
Finding the y-intercept is honestly the easiest thing. Just think about it. Anywhere on that vertical y-axis, what's the x value? It's always 0. So all we have to do is set x to 0 in our equation. For y equals 2x minus 4, we get y equals 2 times 0 minus 4, which just means y equals negative 4. That's it. And here's the best part, a little secret. Remember our formula, y equals ax plus b? The y-intercept is always just that b number. It's a built-in shortcut. Okay, what about the x-intercept? Well, we use the same logic. Anywhere on that horizontal x-axis, what's the y value? It's always 0. So this time we set y to 0. We get 0 equals 2x minus 4. Now it's just a little puzzle to solve. We need to get x by itself, so we add 4 to both sides, then we divide by 2, and we find out that x equals 2. And that's our x-intercept. Simple as that.
We are on to our last big idea for today. We know how to draw a line, we know how to find its crossing points. Now we need to figure out what gives the line its tilt? What makes it steep or flat? Well, this idea has a name, and it's called the slope.
The slope is just a number. That's all it is. It's a number that tells us how steep the line is. And guess who it is? It's our old friend a from the formula y equals ax plus b. The slope just answers one simple question. For every one step you take to the right, how many steps do you have to go up or down? That's the whole idea. We sometimes call it rise over run.
And check this out. Just by looking at whether a, our slope, is positive or negative, we know which way the line is going. If a is a positive number, the line goes up as you move from left to right. It's like you're climbing a hill. But if a is a negative number, the line goes down. It's like you're skiing down a hill. So just by glancing at the sign, you know the line's direction. It's awesome.
Wow. Okay, let's take a breath. We did a lot today. So what did we learn? Well, we learned a function is just a simple one-in, one-out rule. We met our amazing formula, y equals ax plus b, that makes every straight line. We figured out that b is the starting point, the y-intercept, and that a is the slope, the tilt of the line. And we know if a is positive, we're climbing, and if it's negative, we're skiing. You basically learned how to read the story of a straight line.
So here's what I want you to take away from this. You have a new superpower now. You can look at an equation like y equals 3x plus 5, and you can see the story of a line in your head. So my question for you is, where do you see these lines out in the real world? Maybe it's how much your phone battery goes down over time, or how much money you save each week. The world is full of these straight line relationships, and now you speak their language. Thanks so much for joining me today.